Hello! Welcome to the second lecture of Module 1, where we will speak about the blockchain history and future. The goal of this module is to explain the main components of the blockchain technology, recognize its application sectors, and discuss the key historical facts of blockchain technology development. In this lecture, we specifically recall the main historical facts of the blockchain technology development. The table of content of this lecture is as follows. We will speak about the early days, and then we will go through the four main generations of the blockchain technology. Okay, so let's start with the early days. Already in 1982, David Shaun describes the design of the distributed computer system that can be established, maintained, and trusted by mutually suspicious groups. It is the public record-keeping system with the group membership consistency and private transaction computations that protects individual privacy through physical security. The building blocks of the system include physically secure vaults, existing cryptographic primitives, and a new primitive introduced by the Shaun, threshold secret sharing, meaning where some threshold of the partial keys are sufficient to reconstruct the original partial key from which the sub-partial were originally formed. Shaun's suspicious networks were not specifically designed to support digital currencies, but the connection was obvious. Drawing on this work in blockchain technology, Shaun launched a company called DigiCash in 1989. However, in 1995, the company introduced cryptocurrencies, various called digital cash, e-cash, and cyberbucks. DigiCash digital currency promised to deliver many of the features of the modern cryptocurrencies. The company emphasized anonymity as the key benefit, but Shaun was unable to convince banks to support the project, and without an internet infrastructure to support it peer-to-peer transactions and only exchanges, the project failed in 1998. Merkle trees is a tree in which every leaf or node is labeled with the cryptographic hash of the data block, and every node that is not a leaf, called branch in a node or a node, is labeled with the cryptographic hash of the labels of its child nodes. Merkle trees are used to create a secure chain of blocks. It stores a series of data records, and each data record connected to the node before it. The newest record in this chain contains the history of the entire chain. Merkle trees plays nowadays a very important role in the blockchain systems. In 1991, Stuart Haber and Scott Stornetta published an article about timestamping digital documents. The article proposed a solution for preventing users from backdating or forwarding dating electronic documents. The goal was to maintain complete privacy of the document itself, without required record keeping by its timestamping service. In 1992, Haber and Stornetta updated the design to incorporate Merkle trees, which enabled multi-document certificates to live on a single block. In 1998, computer scientist Nick Szabo works on a BitGold, a decentralized digital currency. This is one of the earliest attempts at creating a decentralized virtual currency. A gold project was never implemented, but it is considered to be the precursor of Bitcoin protocol. BitGold combines cryptography elements, mining to accomplish decentralization, timestamp blocks that are stored in a title registry. Blocks are generated using proof-of-work strings. Peer-to-peer computing or networking is a distributed application architecture that partitions tasks or workloads between peers. Peers are equally privileged, equipointed participants in the network. Firstly, the approach was proposed and popularized by the file-sharing system called Napster. Yet, it is now an important architectural component in the blockchain technology. In 2000, Stefan Konst proposed the idea of cryptographically secured chains in a research paper titled Secure Log Files based on the cryptographically concatenated entries. He presented a model where entries in the chain can be traced back from the genesis to prove their authenticity. A model where entries in the chain can be traced back from the genesis to prove their authenticity is the same model as we see now in Bitcoin and other cryptocurrencies today. In 2004, the concept of proof of work was also introduced to verify computational effort and determine cyber attack. This gave a way to hash cache, a proof of concept algorithm that provides denial of service countermeasures. Adam Back introduced hashtags in 1997 to limit email spamming. Then, in 2004, Hall Finney introduced reusable proof of work, a mechanism for receiving a non-exchangeable or non-fungible hash token in return for the RSA-signed token. This system helps others to solve the double spending problem by keeping the ownership of tokens registered on a trusted server. The proof of work approach plays a vital role in the Bitcoin and other cryptocurrency mining. And then the blockchain 1.0, which we can characterize by the introduction of the cryptocurrencies, has appeared. In 2008, developers working under the pseudonym Satoshi Nakamoto released a white paper establishing the model for the blockchain. They conceptualized the theory of the distributed blockchains. It improves the design in a unique way to add blocks to the initial chain without requiring them to be signed by trusted parties. The modified trees would contain a secure history of data exchanges. It utilizes a peer-to-peer network for timestamping and verifying each exchange. It could be managed autonomously without requiring a central authority. These improvements were so beneficial that makes blockchain as a backbone of cryptocurrencies. Today, the design serves as the public ledger for all transactions in the cryptocurrency space. In 2009, Nakamoto implements the first blockchain as the public ledger for transactions made using Bitcoin. This way, it went from concept to reality. In January 3, Nakamoto mined the first Bitcoin block, validating the blockchain concept. The block contained 50 Bitcoins and was known as the Genesis block, or Block 0. In January 8, Nakamoto releases Bitcoin version 0.1 to source fork as an open source software. In January 12, the first Bitcoin transaction took place when Nakamoto sent Hall Finney 10 Bitcoins in a block 170. In October 12, the Bitcoin dev channel was created on internal relay chat for Bitcoin developers. In October 31, the first Bitcoin exchange, Bitcoin Market, was established, enabling people to exchange paper money for Bitcoin. And in November 2022, Nakamoto launched the Bitcoin Talk forum to share Bitcoin-related news and information. When 2019 arrived, Bitcoin was well established and continued its upwards trajectory. In February, Coinbase reported selling $1 million worth of Bitcoins in a single month at the more than $22 each. By the end of March, with 11 million Bitcoin in circulation, the currency's total value exceeded $1 billion. And in October of that year, the first Bitcoin ATM launched in Vancouver. But it wasn't all good news for digital currency. Both Thailand and China banned cryptocurrencies. The US federal court seized some funds in the US, and the FTB shuts down Silk Road, confiscating 26,000 Bitcoins. And then the second generation of the blockchain technology arrived. Hence we have the time where the second generation of the Bitcoin technology has born. And here the blockchain 2.0 refers to a wide range of economic and financial applications that exist beyond simple payments, transfers, and transactions. One of the key emerging use cases of the Bitcoin technology involves smart contracts. Smart contracts are basically computer programs that can automatically execute the term of a contract. When the pre-configured condition in a smart contract among the participating entities is met, then the parties involved in the contractual agreement can be automatically made payments as per the contract in a transparent manner. Despite these setbacks, one of the most important events in the blockchain history occurred. Vital Buterin published a white paper that proposed a decentralized application platform. This led to the creation of the Ethereum Foundation, which launched in 2014. Ethereum paved the way for blockchain technology to be used for purposes other than cryptocurrency. It introduced smart contracts and provided developers with the platform for building decentralized applications. The year 2014 was a turning point for blockchain, as financial institutions and other industries become to recognize and explore its potential, shifting their focus from digital currency to the development of blockchain technologies. In 2015, the Ethereum Frontier network launched, enabling developers to write smart contracts and decentralized apps that could be deployed to a live network. Ethereum was on its way to become one of the biggest applications of blockchain technology. But other important events also launched that year. Nasdaq initiated a blockchain trial. The Linux Foundation launched the Hyperledger project. The 9 major investment banks joined force to form the R3 consortium, exploring how blockchain could benefit their operations. Within 6 months, the consortium grew to more than 40 financial institutions. And then the time arrived to the digital society, which is characterized by blockchain 3. So this again led to the development of the blockchain technology to the new level, resulting in blockchain 3 generation. Blockchain 3 refers to vast array of applications that do not involve money, currency, commerce, financial markets, or other economic activity. Such applications include art, health, science, identity, governance, education, public goods, and many other various aspects of the culture and communication. In 2016, the word blockchain gained acceptance as a single word rather than being treated as two concepts. The Chamber of Digital Commerce and the Hyperledger project announced a partnership to strengthen industry advocacy and education. A bug in Ethereum decentralized autonomous organization code was exploited, resulting in a hard fork of the Ethereum network. The Bitfinex blockchain exchange was hacked and nearly 120,000 bitcoins were stolen, a bounty worth approximately of $66 million. In 2017, Bitcoin hit a record of highly nearly of $20,000. Japan recognized Bitcoin as a legal currency. 7 European banks formed the Digital Trade Chain Consortium to develop a trade finance platform based on blockchain. The Block One company introduced the Electro-Optical System blockchain operating system designed to support commercial decentralized applications. Approximately 15% of global banks used blockchain technology in some capacity. In 2018, Bitcoin turned 10 years. Bitcoin value continued to drop, ending the year about $3,800. The online payment firm Stripe stopped accepting Bitcoin payments. Google, Twitter, and Facebook banned cryptocurrency advertising. South Korea banned anonymous cryptocurrency trading but announced it would be invest millions in blockchain initiatives. The European Commission launched the Blockchain Observatory and Forum. In 2019, Walmart launched a supply chain system based on the Hyperledger platform. Amazon announced the general availability of its Amazon Managed Blockchain service on AWS. Ethereum network transactions exceeded 1 million per day. In 2020, Ethereum launched the Beacon chain in preparation for Ethereum 2.0. Stablecoin saw a significant rise because they promised more stability than traditional cryptocurrencies. There was a growing interest in combining blockchain with artificial intelligence to optimize business process. Throughout these 5 years, there was growing interest in using blockchain for applications other than currency. This trend continued into 2021 as governments and enterprises took to blockchain to handle a variety of use cases. This includes voting, real estate, fitness, tracking, intellectual rights, Internet of Things, and vaccine distribution. Moreover, multiple cloud providers now offer blockchain as a service, and the demand for qualified blockchain developers is greater than ever. In reality, the generation 4 of blockchain kind does not exist yet. There are, however, some attempts to some promises for their development in this technology. Blockchain 4 potentially will focus on innovation, speed, user experience, and usability by large and common mass will be the key focus areas. Potentially, the Blockchain 4 applications include 2 verticals. Blockchain plays a critical role in Web3 development. Because Web3 aims to create an autonomous, open, and intelligent internet, it will rely on decentralized protocols, which blockchain can provide. There are already some third-generation blockchains that are designed to support Web3, but with the rise of Block 4, we can expect the emergence of more Web3-focused blockchains that will feature cohesive interoperability, automation through smart contracts, seamless integration, and sensor-resistant storage of P2P data files. Metaverse are the next big thing for us to experience in the coming years. We are connected to virtual worlds across different touchpoints like social engagement, gaming, working, networking, and many others. Metaverse will make these experiences more vivid and natural. Blockchain for solutions can add in the following metaverse development requirements: decentralization, decentralized data management, security, digital proof of ownership, digital collectability of assets, governance, transfer of value through crypto, interoperability. At the end, Blockchain 4 will enable businesses to move some or all of their current operations onto secure, self-recording applications based on decentralized, trustless, and encrypted ledgers. Businesses and institutions can easily enjoy the basic benefits of the blockchain. We can also see blockchain as innovation, and also as the blockchain as the business usable platform. So let's speak about the blockchain 4 as the business usable platform. So its aim is to deliver blockchain technology as a business usable platform to create and run applications, thus converting the technology to fully mainstream. It has the possibility of inculcating other prosperous technologies such as artificial intelligence with blockchain. Blockchain 4 enables proliferation of a seamless integration of the different platforms, work under single umbrella in coherence to fulfill business and industry demands. The introductory blockchain to put forward blockchain 4 utilizes is Unibright, which enables an amalgamation of various blockchain business models. Another example is CLI platform, which allows integration in blockchain space by permitting cross-communication between different protocols across various services harmonically. The fourth generation has the potential to allow transaction speed up to 1 million transactions per second, which is currently impossible in the existing generations. The use of a particular generation thus depends on the application domain it has to sustain with the corresponding consensus models and respective parameter specifications. For peer-to-peer cryptocurrency exchange, Blockchain 1 still proves to be a simple alternative. Other non-financial sectors like education, healthcare, agriculture, smart homes utilizes the Ethereum platform along with smart contracts to formulate the terms of regulations between the service providers and customers. The third and fourth generation on blockchain is more predominant, where the blockchain works into the backend for several business models and cross-communication is required among several blockchain networks. The last two generations of blockchain is still in its infancy and still undergoing several modifications to become potential enough to serve people. So if you're interested in learning more about the different historical facts of the blockchain, please check the existing web links. Thank you for your attention.